Welcome and welcome back. Today we're going to do something a little bit different. We're going to grind some coffee with my Gatton CNC in hopes of simplifying my custom enclosure designs. Let's grind some coffee with our morning project. I'm going to go ahead and turn on our CNC, and while it gets warmed up there, we're going to get our coffee beans prepared. Now, why is it we would want coffee with our morning project? It's not so much that we would want coffee with our morning project, but it's the fact that we could have coffee with our morning project if we wanted to. We could also have something else here, and we'll go over that in a little bit. So now that we have this plugged in, this is connected to the CNC. Let's go ahead and make sure our machine operates. Spindle turns on. All right, I think it's time to grind some coffee. I kind of like a finer ground, so we'll go 2 more times. And there we go. We just ground coffee with our Gatton CNC. I wanted to use coffee as an example today, just to open your minds a little bit to what could be when it comes to the Gatton CNC. Do you know how I wired that in? Before we get into this video, I would like to mention that this video is not going to be for everybody. If you already know the internals and the workings of the components of a CNC, this video is probably going to be pretty boring and not for you. I've designed this video to be more for people who are like myself starting out in the CNC hobby, who are looking for more information on how to design a CNC. If you wanted to design a CNC, what it takes to design a CNC, or if you just want to purchase a plug-and-play ready-to-go option. Who I really hope gets the most out of this is somebody who's already been doing a little bit of research on enclosures and has an idea of what they would like, but cannot find the exact combination out there. Maybe something close, but it doesn't incorporate the things that you need to fit your build. When I mention enclosure, I'm talking about something that can be considered a plug-and-play unit that you buy, has all the components already inside, and all you have to do is connect your wiring and you're ready to go. I'm also referring to enclosures as a box that houses the components for your CNC. If building or wiring custom enclosures is not something that's right for you, please check the description below. In the community, there's a resource that is available that can build plug-and-play custom enclosures. They may not be available for every situation, but if you check the website, they might have a solution that can fit your needs. If you would like to build a custom enclosure, or you haven't found something that quite fits your needs exactly, I'd like to show you what I was able to accomplish. I have 2 enclosures. What is here is normally incorporated into one enclosure and sold as a plug-and-play unit, which is very simple. I decided to separate it just in case I needed to make a little maintenance on one unit and not the other, or just take one box off. It was a little bit easier for me to manage. By also making custom enclosures, I could design how I wanted it to attach to my machine. I left a little bit of a lip on each enclosure that allows me to create a clamping system that will hold my enclosure onto my CNC and allow me to take it off with just a couple screws. And since they have quick connections, or which is designed as a plug-and-play box, it's toolless to disconnect all the connections, and then it just takes a screwdriver to take it off. By also designing a custom enclosure, it allowed me to have the ventilation that I wanted. I happen to be in an environment that can reach up to 110 degrees in the summer. I wanted to make sure I had something to where my drivers were going to be cool and have ventilation. So I opted to go for 2 larger fans and then put filter material at the bottom just to make sure that I could have the fans running pretty much non-stop and not be pulling a bunch of material into my enclosures that I'd later have to clean out, or that could degrade the lifespan of my components. I wanted to have quick access to the inside of my enclosures, so I put latches and hinges on my boxes so that if I needed to, I can get into my enclosures at any time really quick. I also designed them so that I can open them in the smallest amount of space possible and give me the most access. So this one will open up. And then this one, should it opened up, would take a lot more space, so it opens sideways. Now that we've had a brief look at the enclosures, let's mount them to the CNC. I've designed a clamping system to hold my enclosures to the CNC. To make installing them easier, I only unscrew one side. You'll see that I use 3-prong connectors for my enclosures. Not only did it seem to be the most common, but it's the one that I'm most familiar with. Using a 3-prong connection also allows me to have very small leads coming out of the enclosure for power, and then an extension cord then becomes my power cord. To make installing the enclosure easier, there's a ledge that the enclosure rests on. This way I don't have to hold the weight of the enclosure while I install it. The clamps that I'm reinstalling are holding the enclosures by the small ledge I had shown earlier. I won't be speeding up the full install of the enclosures because I'd like to give an idea of how long it takes to install from completely off the machine to completely on the machine and ready to run. The intent of this video is not to be a detailed wiring diagram video. It's meant to show how the wires run through my enclosures. While a lot of CNC machines can use a lot of common components, the wiring configurations can vary. If your build has a CNC offline motion controller similar to mine, I will have a detailed wiring video in the future. If your build is not similar to mine, as long as you understand the pathing or the routing that the electricity or information is going through the components, then you'll be able to make the connections. This connection can be as simple as connecting one component directly to another with wire, or having something in the middle like a terminal block, aviation connector, or 3-prong plug, which allows components to be quickly disconnected and reconnected. To connect the drivers to the motors, I chose 4-pin aviation connections. These connections allow information to be sent from the drivers to the motors. This first connection is for the motor on the y-axis. This connection is for my x-axis. We'll then connect the z-axis. Then we'll connect the last motor, which is the second y-axis. The first connection I'm going to make for my offline motion controller enclosure is going to go to my power enclosure. This is the connection that will activate the pump for my water-cooled spindle. The next connection I'm going to make is the connection that will allow the offline motion controller to send all the information to the drivers. Then we'll make the connection for the power to the offline motion controller. On the underside, we have a 10-pin connector. This 10-pin connector allows our wiring to take power from our power enclosure over to our driver enclosure. I chose a 10-pin for this application because this would allow me to power 5 components, my offline motion controller, and 4 drivers. Each component requires a positive and a negative, so 2 wires each, hence 10 pins. I wasn't sure how much of a difference it would make, but I did try to separate the signal and the power cables, keeping power more on the bottom and signals on the top. This also became another reason for me having two separate enclosures, a separate power enclosure and a separate driver enclosure. Since I decided to include my VFD power in my power enclosure, I figured I'd just up the chances of having unwanted noise. By separating them, I figured I was just upping my odds at having a clean signal. The cable I'm connecting now is a 4-pin aviation plug that carries power directly from my terminal blocks over to my driver enclosure that powers the fans for the ventilation. This is the cable for my VFD. This is going to connect to the bottom of the power enclosure. This plug is from the pump that's in the 5-gallon bucket for the water that runs through the water-cooled spindle. With our enclosures mounted, this CNC only needs power from extension cables and it's ready to run. Let's take a look at what we have so far. On the side we have open space. Later on I plan on including drawers or cabinets for storage. On the front so far we have our offline CNC motion controller in its cradle. We also have our VFD. On our other side we have our 5-gallon bucket for our water-cooled spindle. It can sit on the bottom of the CNC for transportation, but it sits on the ground while the CNC is in operation. Later I plan on having a water bucket holder, and I hope to have a video on that as well. I have two extension cords down here, and these are going to be my two circuits. They're plugged into the wall. I do not have my power switch that I'm going to use here, but the entire machine will be activated off of one on-off switch. So we're going to take one of my circuits here, and we're going to plug it into my power circuit for my spindle, or my VFD, and then from the VFD it's going to go to the spindle. Let's plug this extension cord in to that circuit. All right. I built in some troubleshooting. So with these plugs are definitely not the cheapest option that are going to be out there. But I selected these plugs because when they have power, they illuminate, which allows me to see which plugs may have power and which may not, giving me easy troubleshooting to my enclosures. This is going to be the plug for my VFD. The power does come in and it is live, but it does not have power flowing out from the bottom because the relay has not recognized that power is flowing through this circuit, which controls most of the CNC. So let's turn that on. With my enclosure design, all I need for power is an extension cord. By plugging the extension cord into a power strip, I effectively gave myself an on-off switch. This is not an on-off switch that you would want to use as an e-stop, since the VFD is controlled with this power switch as well. This is just a simpler way of turning on and off the machine without directly plugging and unplugging the cord manually. I'm just manipulating the machine a little bit to show that this is a fully functioning CNC. All we need is the software to plug in with a USB and we're ready to run a file. I did not choose to control the speed of my spindle through the offline controller. I chose to use the potentiometer on the front of the VFD. Now that power is flowing onto the main CNC, we're going to see that the VFD has power flowing to it, and it is now on. I could run the spindle if I needed to. And then that power is on flowing through this, which is going to go to the cooling, the water cooling for my spindle. Since I did design these as a clamping system, and these are designed to open while running, I could also check all the lights to see what has power, what doesn't have power. I also do have breakers or additional switches to turn power on for the CNC or the spindle. And then same with my driver enclosure. I can then open it up and check the lights to see if all have power. Power is provided through the CNC through this input here. So our main power is going to come in and run to our terminal blocks down here at the bottom. We're going to have our low terminal block, our neutral terminal block, and then our ground terminal block. From these terminal blocks, we'll be able to supply power to the rest of our components. This power supply is going to be used to run our offline motion controller. In order to supply power to this, we're going to draw from our terminal blocks at the bottom. We're going to connect our load, our neutral, and our ground to a corresponding terminals on our power supply. In order to provide power to our offline motion controller, power is going to flow from this power supply out into this 10-pin connection and then over to our driver enclosure. Our power for our offline motion controller just routes directly through this box. I did not plan on having it connect to both boxes. Had I had known that, I would have just had it wired through one box. But since I did not, and I did have to have the wires come in here for the signals, I just wired the power through the 10-pin directly through to a 2-pin on this side that goes to the offline controller. The offline controller's power is also in this wire bundle, and that connection is this one here. These two power supplies were supplied with the motors that were a package deal that I selected for my CNC. In order to supply power to these power supplies, we need AC power, and we're just going to grab those from our terminal blocks down here at the bottom. We're going to run our load to our load, our neutral to the neutral, and then the ground to the ground terminals. In order to provide power to the drivers, the power will come out of these power supplies and run to this 10-pin plug. Our power for our drivers will enter in through our 10-pin down here and be routed in, and then we'll route off to each driver. The MPG, or the mobile pulse generator, gets wired directly to the offline controller. The offline controller will send the signals to the drivers through this connection. The signal from the offline controller enters in from the top of this enclosure here and then runs to our different drivers. I have two Y drivers, so the signals did need to be split. So I used a terminal block to split one signal into two and then routed them down to our drivers before sending the signals out to our motors. The drivers will send the signals through the motors through the aviation connections here. There will be 4, one for each motor. Those go directly to each motor. The power for the VFD that also powers my spindle comes in through this connection right here. Power for the spindle is going to enter an enclosure from right here. This is a separate circuit, meaning that it's going to have a separate breaker in our electrical panel wired to it, not a separate outlet. That's going to be the same circuit in most cases. Power will come in and pretty much make a direct line out to the plug that I'm going to be plugging in our VFD for our spindle through this connection down here. It does make a stop through another breaker as well as a relay that only allows power to flow directly to the plug once it recognizes that power to our entire CNC machine is on. So I know I wanted something that would allow my VFD to turn on once I turned on the power switch to my CNC. I also know that I wanted my VFD to turn off once the power for the CNC was turned off. I needed to slow down and figure out how I was going to get this accomplished. With so many wires and connections, it was very intimidating. I decided I was going to take a reverse engineering mindset and try to take one component at a time to figure this out. So once I had a basic understanding of watts, volts, amps, AC, and DC, it allowed me to get a better picture of how I could customize my enclosures to my needs. Reverse engineering is basically taking something or a process that is already completed and dissecting it to find out how it works, to gain knowledge, or to make it better. How I use reverse engineering is almost as if you're looking at a maze. Instead of starting at the beginning and finding out how to get to the end, I start at the end and work my way towards the beginning. The easiest way I can explain this is in the beginning of a maze, you may have 3 different paths, but only one takes you to the right spot. If you start at the right spot, you're only going to have one path that will take you back to the beginning, where when you turn around, you will see there were 3 paths originally. I may not have known the exact terminology for the component that I was looking for, but I knew the function that I wanted it to do. And by tracing it back to the power source, I could identify places that I can install this component. And since I know the functions of the component, I was able to go onto the web and look for the functions and then the terminology for the component that I was looking for. A lot of times I found out that what I may have wanted were more than one component put together. And then once separated, it was really easy to understand those functions, and I could see how I could personally wire and build my enclosures. Let's take a look at the enclosures and see how I was able to wire the outlet I used to grind the coffee earlier in the video. Some of you who have seen my previous videos already know, but let me go ahead and move the camera back. So look at the enclosures there. And then if we remove the example and plug back in what is normally here. This is the water pump that's in a 5-gallon bucket for my spindle. And then we activate that. My water pump for the spindle comes on. Now that I showed you that the receptacle I plugged the coffee grinder into normally controls the cooling for my water spindle, can you guess how I wired it? This is the button that activates the water cooling for the spindle, and that is wired through this cabling here, which will come in here, and that is going to be this cable that comes into the power enclosure. It acts as an actuation for the relay that's in here. This is where the receptacle for our water pump goes. In order to get power, we're going to draw from our terminal blocks at the bottom, and it's just going to route up to our receptacle. These are solid state relays that allow me to control the flow of power. It allows me to turn on or off the power. I placed one in the flow of the receptacle to my water pump. So after the power is grabbed from the terminal blocks, they'll come in And then the power will come through this relay and then out to the receptacle, giving me the ability to turn it on and off with a switch for my offline controller enclosure. This solid state relay is in the path of the VFD power. That would allow the power to turn on and off with the CNC. These solid state relays were added just to give me a little bit of extra function. If we take the solid state relays out, we would still have power to our receptacle. It would just be constant. We'd also still have power for our VFD. It would also be constant. We would just have to control the VFD by unplugging manually and plugging in manually. Knowing that I was going to have a dedicated receptacle that I could control with an on-off switch, a 3-prong plug just seemed to make the most sense. Not only was it the one I was most familiar with, but it really did seem to be the one that was at the end of most components or accessories that I'd add to my CNC. This receptacle also makes it very easy for me to upgrade my cooling system in the future. There are many other options that can be plugged into this receptacle. If you don't have a spindle on your build, this can be used to control your router. You now would effectively have an on-off switch for your router. It could be an on-off switch for dust collection. It could also be an on-off switch for lighting. Basically, it can be an on-off switch for anything that has a plug. What would you do with this? The Gatton CNC and everything on this CNC was purchased. There was nothing sponsored or given for this video or for purposes of my use. I have not had this long enough to where I feel comfortable doing a review. But I do feel comfortable helping those who may be looking to purchase this product. One of the biggest pieces of advice that I could recommend is to find someone who has completed a build similar to what you're thinking of doing. This may help you through your process. It definitely helped me. With that being said, there's a lot of information that you may be able to take from this video, even though your build's going to be very different. There's so many different builds that can happen in the CNC world. It's going to be very rare when 2 builds are going to be exactly alike. If wiring is just not something that you're wanting to do, but you are looking at getting a Gatton, please check the description below and check out the website hobbybox.com. It partners perfectly with this machine. It may have something that fits your needs. Hey, you made it this far. Thank you for watching my videos. I do truly appreciate it. As a bonus, I'm going to put timestamps in the description so that you can go back and reference the information in this video. All right, in the name of fun, we're going to do something else also. All right. Since I also designed these, dust control was something I was very concerned about. Since I designed these, I figured maybe we'd have a little fun. And I have my bin for my dust cyclone, and I know that while we're cutting, chips are kind of a concern. One of the very first things you will find out is how much dust is in MDF So we're going to do something kind of like a stress test here. So what we're going to do is, now that we have some dust laid out here, we're going to dump it right down onto our running enclosures, clean them off, and see what it looks like on the inside. Let's see here. All right, I won't be able to get cleaned off 100%, but that's good enough for our example. I'm gonna go ahead and turn off the machine so the fans stop. All right, see some of the suction loosening this. Alright, since this one swings open, I have less chance of getting stuff in there. Let's open this one first. Not too bad. You can see most of that just fell from the top, but that is what it looks like on the inside after dropping a bunch of dust.